tube amps, speakers, and impedance. So what is impedance? Whatever opposes the flow of current in electrical systems is called, or can be measured as, resistance. Impedance is sort of like resistance, but it only opposes alternating current, whereas resistance opposes both AC and DC. We will probably be using the word resistance more in this video, but just be aware that the right term for speaker resistance in the tube amplifier world is impedance. The symbol for impedance is Z, and it is measured in ohms. The more resistance, the higher the value, and the less resistance, the lower the value. Let's look at it this way. Your tube amplifier is designed to work against a certain amount of resistance. Your speaker or speakers provide that resistance. If your amp sees either too much or too little resistance, it's not going to work as intended, or be as efficient, and might even get damaged. Impedance mismatches. This may not be the most scientifically correct analogy, but here's a way to look at impedance. Let's think of your tube amp as a car and your speaker or speakers as the road your car is moving along. Your car is seeing just the right amount of resistance when it's moving on a straight and level gravel or asphalt road, as it was designed to do. Let's pretend that this is a perfect impedance match, like 8 ohms into 8 ohms or 16 ohms into 16 ohms. With tube amps, it is recommended that you always match the speaker output to that of the speaker. How about, what if there was too much resistance? You could think of this like driving up a steep hill, not very efficient or optimal for the car nor its engine, at least not in the long run. Okay, the hill ain't that steep, but you get what we mean. We can think of this as connecting an amp's 4 ohm output to a 16 ohm speaker. Depending on different factors like how loud you play and for how long you play for, this might damage your amp. Conversely, if there's too little resistance, it isn't good either. Using the car analogy, we could say having too little resistance would be like driving on ice or some other slippery surface. This would be like connecting an amp's 16 ohm output to a 4 ohm speaker. And again, depending on different factors, this could damage your amplifier. How about infinite resistance, or no resistance at all? These types of situations can be the ultimate evil for your tube amplifier and are likely to cause problems and should be avoided even more than mismatched impedances. Imagine pressing down the gas pedal while your car's wheels aren't making contact with anything. Not very optimal for the car's engine, we would assume. And no, we're not mechanics either, so. This would be like zero impedance, or near zero impedance. A short circuit in your speaker cable or a very badly damaged voice coil could result in this. Also, depending on how the amp is built, having no load connected to the amplifier's speaker outputs could as well result in zero impedance. Then imagine you've got your car's front bumper against a thick brick wall and you put the pedal to the metal. Same thing, not very efficient for the car's engine. This would be like infinite or near infinite impedance and can be achieved on some amps by not connecting any load like speakers or a load box to your tube amp speaker output. Not recommended. So, how do you make sure you're always on the safe side and connecting your speakers correctly? Well, first we got to look at the 2 ways you can wire and connect speakers, parallel and series. Here are a couple of easy examples. If you wire 2 speakers of the same impedance in series, you can simply add the impedances and you'll get the total resistance of the speaker system. Like if you have 2 8 ohm speakers wired in series, the total load is 16 ohms. However, if you wire those same 8 ohm speakers in parallel, your total resistance will be 4 ohms. Now, when you start adding speakers of different resistances, the math isn't as simple as doubling or dividing the impedance. You can look up these equations if you want, but for our purposes here, it's enough that you know that if you add in series, the impedance goes up, and if you add in parallel, the impedance goes down. Adding speaker cabinets to an amplifier usually happens in parallel. Let's say you have 2 cabinets both rated at 16 ohms. Their total load will equal 8 ohms, and you would want to connect them to your amp accordingly. If you have 1 cabinet rated at 16 ohms, you would of course connect it like this. Some amp manufacturers even help you out and make it harder for you to mess things up. For example, amps built by the likes of Marshall or Orange might have markings like these next to the speaker outputs, or like these. Daisy chaining speaker cabinets, like connecting a cabinet to another cabinet, might look like it is in series, but it could be either or. A lot of the time, daisy chaining speaker cabinets happens in parallel, but there are also cabs available where you can choose to daisy chain in series or parallel. So make sure you know what you're doing when daisy chaining cabinets. For example, if you'd like to daisy chain two orange PPC-12s, you do it like this, not like this. And this is because orange PPC-12s daisy chain in parallel. What is a safe mismatch, and is there such a thing? Believe it or not, there are differing opinions on this. Since we're not amp builders or scientists here at Dead Lizard's lab, we're going to cop out and recommend that you always match your impedances. If you, however, absolutely have to mismatch for whatever reason, refer to your amplifier's user manual or ask the manufacturer directly. That said, let's get into this mismatching controversy a little bit. It seems a lot of people are under the impression that a safe mismatch in the realm of tube amps is to go from a smaller rating at the amp speaker output to a higher rated speaker cabinet. However, surfing the net a bit, one realizes there are many differing views on this. Some say having a higher load than what your amplifier is set to could create what is called flyback voltage, which in turn could be harmful to the amp's power transformer. Others say having a lower load than what your amp is set to could make the amp push more current, and this could result in shorter tube life, for example. A lot of people might agree that both are true. Some of those people might say both are true, but only one is truly harmful to your amplifier. Others might say both are true, but amplifiers can take a mismatch as long as the mismatch is 2-to-1 or 1-to-2. Like a 16 ohm load connected to an 8 ohm amp or the other way around, but not like a 16 ohm load and a 4 ohm amp or the other way around. Others will say it depends on how the tube amplifier is built. Others say it depends on how loud or how long you play. If you dive into that rabbit hole, you might find that there are even people who seem to be authorities on the subject whose thoughts differ on which way a mismatch is safe and which way it is not. That rabbit hole is yours to dive into if you so wish, but we want to keep things relatively simple here. So let's recap. 1. Always match your impedances. But if you, for some odd reason, don't want to, refer to the manual, or even better, ask the manufacturer what is safe and what is not. On a side note here, some manufacturers do even recommend experimenting with mismatches in their manuals, so mismatching is not always so dangerous. But again, if you don't know or haven't read the manual, it's better to play it safe. 2. Never turn your tube amp on if there is no speaker or load connected, especially when the amp is seeing an input signal from your guitar or some other source. This could result in the amp seeing an infinite impedance, and this could be harmful. 3. Never use broken speaker cables or anything that could end up short-circuiting. This would be like having a zero impedance, and it could end up damaging your amp. Okay, that's it. Leave a comment if you have any questions or if you perhaps spotted a mistake. Thanks for watching.